function n, let t from v to v is a linear transformation with only one has eigenvalue, then which of the following must be true? First option, t minus I equal to 0. Second option, t minus I all raised to n minus 1 is equal to 0. T minus I all raised to n is equal to 0. T minus I all raised to 2n is equal to 0. Now here given t is equal t from v to v is a linear transformation with 1 is the only eigenvalue. So now the corresponding matrix is this is dimension n, so is an n by n matrix with all eigenvalues are 1. We know that identity matrix I n by n has all eigenvalues 1. Then option 1, 2, 3 and 4 are true, but this is not the only case. If I choose for n equal to 2, a 2 by 2 matrix A22 is equal to 1, 1, 0, 1. So this is a triangular matrix. So eigenvalues are 1, 1. That is diagonal entries. So all eigenvalues of this matrix is 1 and n equal to 2 here. N equal to 2 here. Now I am taking instead of t I am taking A. So A minus I matrix is 0, 0, 1, 0. So here all eigenvalues are 0. So now this is not equal to 0, right? A minus I or t minus I equivalent to t minus I is not equal to 0. Now I am taking second option, t minus I all raised to n minus 1, which is equal to a minus I all raised to n. N is 2. 2 minus I. That is a minus I itself. But here a minus I not equal to 0. Now next option is a minus I or t minus I all raised to n minus or all raised to n, which is equal to a square. If you multiply this, you will get 0. If a minus I all raised to n is equal to 0, then a minus I all raised to 2n is equal to 0. So option from here, option 1 is, what about options? Option 1 is t minus I equal to 0. That means a minus I equal to 0. That is false. And option 2 is t minus n minus 1. That is not equal to 0. So second option is also false. And what about 3 and 4? So from the example it is true. But how to conclude that? So for a minus I, here this is a all eigenvalues are we know that all eigenvalues of a is equal to a are 1. Then what will be all eigenvalues of a minus I, which is equal to 1 minus 1, 1, 0, which is equal to all eigenvalues of a are 0. If all eigenvalues of a are 0, then A is nilpotent. Nilpotent. What do you mean by nilpotent? A raised to some k is equal to 0 matrix. So all eigenvalues of A minus I are 0. So A minus I is nilpotent. That means A minus I all raised to some k is equal to 0 for k less than n. So here we will get t minus I all raised to k equal to 0. Therefore k less than 1. Therefore option 3, option 4 are correct answer.